Here we're going to do question 3, algebra, achieved in merit questions. The first one here, I can see that this here, we've got some fractions. We're going to have to add fractions, so I cross multiply. So what I'm going to do is I'm going to multiply that direction, and finally multiply the denominators. So I've got x plus 2 in the first bracket. I'll just switch those letters around, and I'm timesing with x plus 2 when I'm multiplying that way. I multiply this one. Remember, we've got an addition in the middle, so it's 2x plus 5, and we put that over the denominator, multiply, which is x plus 5 and x plus 2. Now I'm going to use FOIL to do the top line. X times x is x squared, plus 2x times 2 times x is x times 2 is 2x, plus another 2x, plus the 4. So that's the first one done. And then I add it to the second one multiplied, which is 2x plus 5. And the denominator, because there's nothing to add it to, I'm just going to leave it as x plus 5 and x plus 2. I'm not going to bother expanding it. So then, tidy this up, we can see we've got x squared. Now I've got 2x, 2x, and 2x. That makes 6x. And I've got 4 and... did I multiply that? No, 2 times 5 is 10. That should be 10 there. So 4 and 10 is 14. And that is divided by x plus 5, x plus 2. So here we've done our first achieved question in question 3. Right, this is a single number. Now I'm going to do this in two parts. We don't know what log to the power 3 of base 3 of 9 equals, so I'm going to put n. Nor do it, well, we'll do this one first. So 3 to the power of n equals 9, because logs are powers, there's your base. So it must be 3 squared is 9, right? So n must equal 2. And then we'll do the same with log base 2 of 64. Log base 2 of 64, we don't know what it is, so I'll call this m. But we know 2 to the power of m equals 64. And so if you multiply your 2 times table, 2, 4, 8, 16, 32, 64. So m must equal 6. So to write it as a single number, now how do I go about doing that? We've got log base 3. We've got that we know that that is 2 because we found what it equals. So we've got 2 plus, and log base, this one here is 6, 2 plus 6, which equals 8. All done? Cool. So there's our answer. Right, here we go with part 3. Part C here. We want a rectangular ink stamp as shown here. The whole thing measures 30 by 50. So this here would be 50. I'll just get my pen. 50 that way and 30 that way. So we have to find an expression of x for the area of the rectangular ink stamp. This 50 has 8x and an x that has 9x missing from it. So 50 minus 9x will be the width of the stamp. And this 30 has x and another x missing from it, so 30 minus 2x will be the height of the stamp. So there's the area of the stamp. That's an achieved mark for doing that. We could expand that out, and if you expanded it out, you would get 1,500 when you multiply, minus 100x minus 270x plus 18x squared. Simplify that a little bit more, and you get 1500 minus 370x plus 18x squared. It says that it wants 160 centimeters squared, so 160 is going to equal all of this. Now, to make it equal 0, I have to shift the 160 to the other side. And so I take 1500 minus 160 off, and I get 1340. I'm going to put my 18x squared at the front minus 370x. You can solve that with the quadratic formula or your calculator. It won't factorize easily, and see what you get. So using a equals 18, b negative 370, c equals 1340, we get these two answers. One of them is a minimum. This will give you the minimum area, and this will give you the maximum area. And so we're using this one here for the maximum area, and put it in the dimensions that we've got here. 50 minus 9x will be your base, and 30 minus 2x will be your height. So we're going to do 50 minus 2x, that's 4.9693. That will give you one length, and the other one will be 30 minus 2, lots of 4.693. That will give you your other dimension, and that is going to be dimensions of 20.6 centimeters by 7.76 centimeters. Here we go. That's for merit.